Okay, so here we have January 2021, 1HR. So this is the regional paper, and it's the first paper. So make sure you have black ink, pencil, protractor, ruler, scientific calculator, compass, rubber. Have all your equipment ready, and also make sure you've eaten something for breakfast. Right, are we ready to start? So here we have the formula sheet. This formula sheet you should refer to. We should really look at the formula sheet and always know what's on here. Okay? So we have arithmetic sequence at the top. We have the quadratic equation. We have area of a trapezium, trigonometry, volume of a cone, volume of a prism, volume of a cylinder, and volume of a sphere. Now we've done a lot of work on volume recently, so we know that all of these are at the front. Remember, the formula sheet is here to help you. Okay? When in doubt, seek the formula sheet out. Brilliant. Okay, question 1. Now, question 1 is a show that question worth 3 marks. It's really important. I know that we can all multiply by fractions, but we have to show that we can multiply by fractions. And in the mark scheme, lots of people do not get the full 3 marks because they haven't presented it efficiently and they haven't actually done the show that. Okay, so step 1. When we multiply fractions, we should get we should convert them from mixed numbers to improper fractions, okay? So, 3 and 1/5 is 16 over 5, okay?
Yeah, 3 times 5 and then
because remember, 3 whole ones is how many fifths? It's 15 fifths, isn't it? And then we have 1/5, okay? Multiplied by 1 and 5 sixths. So a whole one is 6 sixths plus 5 sixths, 11 sixths. Perfect. Right, we now need to multiply these. So by the way, we get 1 mark for both of these. Okay, so this is 1 mark right now. Now, we need to actually do correct cancelling or multiplication. Now, as you know, we've been working with algebraic fractions. We are going to do the cancelling method. Okay? We have to see, if we think about this, we have 16 times 11 over 5 times 6. Wait there guys, you don't need to write this red bit. Without actually working this out, okay? Do they have a common factor on the numerator and the denominator? Do any of the values, remember this is multiplication now, so we only have 2 terms technically. We have this term and this term. Do we have a common factor on the numerator or the denominator? The common factor is 2.
Yes.
Because 16 and 6 are both in the 2 times tables. So we could cancel this, okay? So if we were to cancel this, we're going to have 16 divided by 2 is 8. 6 divided by 2 is 3. This makes it a bit more manageable for us to multiply. Showing this and then writing 88 over 15, this gives us another mark, okay? We either have to show this or we could do it the red way where we have 171 over 30, okay? Either way, if you do the red, these 2 or this one with this cancelling, there is your second mark. Right. Then the third mark is dependent on this. If you haven't shown either all the black working or the beginning black and then the red working, you cannot obtain the last mark. The last mark is then converting this top-heavy fraction into a mixed number. How many 15s go into 8? 5. 5 is going to give me 75. How many is left over? 13 over 15. And then if you want to, you can write therefore improved. Now, it's really important that once you get from 88 over 15 equals 5 and 13/15, you actually have to write this statement here. Or you can write equals right-hand side. However, we've started here, we've shown our work and we've got to the end. They want to see that you've gone from the left-hand side and you've managed to get to the right-hand side. We have shown that starting here, we've able to manipulate this to get 5 and 13 over 15. Okay, question 2. So, this type of question isn't a show that question. However, let's work through this. Now, basically, how I would approach this question. First of all, we read it. Given that A is less than B is less than C, the 4 whole numbers AA, B and C. Okay, so first of all, I know I should read the rest of the question, but I do get a bit AA, B, C. I'm literally going to write A, B, C. And we know that this is in ascending order because we know that A is less than B is less than C. And it says 4 whole numbers, A, B, C. Okay? I know that we are going to have to figure out A, B, and C because it says it in the question part. So, it then says, a mode of 7. What does that tell me if there's a mode of 7?
There's at least 2 sevens.
There's at least 2 sevens, okay? Which letter has been repeated twice? A. So that gives me the conclusion already that A must be 7 and 7. Okay? A median of 8.5. What does that tell me?
So the number.
When it's in order, the middle number must be 8.5. When I put this in order, where is the middle? In between A and B. So in here, in the middle, technically is 8.5. What does that then tell me? How did I get from 7 to 8.5? I added 1.5. So how would I get from 8.5 to B? I add 1.5, which is going to give me 10. So I now have worked out the next value because I know between 7 and 10 is 8.5. Okay, so I'm going through the steps logically. Then it says a mean of 9. What do I know about having a mean of 9? I know that if I add up the 4 numbers and divide it by what? 4, this gives me 9. I've actually drawn a picture to represent this. So what does this actually mean? How can I now manipulate this? This now means that the 4 numbers added together must equal 4 times 9, which is in fact 36. Okay? So you can see all this deductive reasoning that's happening. So 4 times 9 is 36. Do I know some of these numbers already? I do. So I know this is 7, this is 7, this is 10. So 7 plus 7 plus 10 plus something must equal 36. So I get 24. I know that this is 24. 24 plus what equals 36? 12. So therefore my last number must be 12, according to our reasoning. Now what I'm going to do is before I write the answer, I'm actually going to double check everything. So first of all, a mode of 7. Do our 4 numbers have a mode of 7?
Yeah.
Yes, I have more than 2 sevens. Okay, check. A median of 8.5.
Yeah. Yes.
Well, let's double check. 7, 12, 7, 10. What's in between 7 and 10? How do I work out the median? I could add the 2 numbers together and divide them by 2. 7 plus 10 is 17 divided by 2 is 8.5. Brilliant. Or I could just draw my number line. 7, 8, 9, 10. What's in the middle of 7 and 10? Between 8 and 9, which we know is 8.5. So we know that's right. And then a mean of 9. So let's work this out. So the mean, we add them all up. What is 7 plus 7 plus 10 plus 12 divided by 4? This should give us 9. Let's see if it's true. 7 plus 7 is 14, plus 10, 24, plus 12, 36 divided by 4 equals 9. Yes, I know I'm right. So there we go. 7, 10, 12. Now, all the working I've done in the pink, this double checking, I would do this, I would do it in my head really to double check it's right. But also, you know, at the end of the exam, when you have extra time, sometimes you don't use it all. I would then go back and use a different colour pen and double check this makes sense, working backwards, not just reading this and going 7, 7, 10, 12, yeah, blah, 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 done. I would go and work it out another way to know I was correct. Okay. Question 3. On the number line, show the inequality -2 is less than or equal to y is less than 1. Well, first of all, -2 is here and 1 is here. Now, if it includes -2, what do we have to do? Fill in the circle to know that this is included. Does it include 1? No, because our inequality is just less than. This is less than and including, this is just less than. So, we draw a straight line, and there we have it. Nice and easy, 2 marks. Next part of the question. N is an integer. Write down all the values of n that satisfy -3.4 is less than n is less than or equal to 2. Well, I could actually draw this on my number line. Okay? If I have -3.4 here, let's say, and it goes to 2. So if I think about this, it goes from -3.4, does not include it, and it goes to 2 and it includes it. So what are the whole numbers in between? Drop my pen. The whole numbers in between this are, can we include -3? Yes, because it's in between here. So we're going to have -3. Can we include -2? Yes. -1? Yes. 0? Yes. 1? Yes. How about the number 2? Yes, because it's also included. So for this one, in terms of our method and presentation, we didn't really have to present a lot. It's just making sure we understand this correctly, and that this is just more common sense of what integers satisfy this, and you can use the number line to help you. Question number 4. A train journey from Paris to Amsterdam took 3 hours, 24 minutes. The total distance the train travelled was 433.5 kilometres. Work out the average speed of the train. Give your answer in kilometres per hour. So first of all, I've read this question. I've got speed, distance, time. What am I thinking? Speed equals distance over time. I'm going to write that formula down. Now, it's very clearly said that the train journey from Paris to Amsterdam, so we know that time equals 3 hours, 24 minutes. Okay? We know the distance equals 433.5 kilometres. We want to work out the speed. It wants kilometres per hour though, so lots of students make mistakes on this. First of all, I'm going to write down everything I know, and then I'm going to write down what I don't know, or what I need to find out. What don't I know yet? The speed. So this is what I'm looking for, isn't it? In the question, it clearly says kilometres per hour. So first of all, is our distance in kilometres? Yes, so we do not need to convert this. Is our time in hours? No and yes. It's in hours and minutes. So we need to convert our time first to make this appropriate. So 3 hours and 24 minutes. Lots of students make the mistake of writing 3.24. Is that correct? No, because 3 hours 30 minutes is what?
3.5.
It's 3.5. It's 3.5 hours. We wouldn't say 3.3, would we? Okay, so minutes is out of 60. So what we're going to do is we're going to have 3 hours and 24 out of 60. This is going to give us our decimal. What is 24 divided by 60? I think it's 4/10. So it is 4/10. So this is 3.4. So 3 hours, 24 minutes is 3.4 hours. Okay? So now, our time, I'm now going to change it to 3.4 hours. Okay, so now, do we have kilometres? Yes. Do we have hours? Yes. I can now substitute into the formula. So speed equals our distance in kilometres divided by our time in hours. I'm going to put this into my calculator. 433.5 divided by 3.4, and it's going to give us 127.5 kilometres per hour. There is obviously more than one way to do this question. You could have converted everything to minutes first and then do hours later. However, in terms of looking at the steps, I think this is really appropriate. Now, the last thing I want us to do is to check that this makes sense. How do we check this makes sense? Right. If we work backwards, so we're going to work backwards. Are we ready? We're going to do what I call a common sense check. Think about it. If it took roughly 3 hours, 24 minutes is what? 3.5 hours? Roughly. 3.5 hours to travel, let's call this 450 kilometres, yeah? So roughly 3.5 hours to travel 450 kilometres. Would it make sense if we travelled 130 roughly kilometres an hour? Yeah, I mean, we could even do a side note, couldn't we? And we could say, right, if we travelled 130 in the first hour, this is 1 hour. In 2 hours, it'd be 260. 3 hours, 390. So 3.5 hours, what's half of 130? 65. So 3.5 hours is going to give me roughly 450-ish. Does that make sense? We travelled 433. We're estimating 450 roughly. So it does make sense. So I know I'm on the right lines. Okay, question 5. So, question 5. The diagram shows a cuboid and a cylinder. The dimensions of the cuboid are x by 12 by 5, and the volume of the cuboid is 270. Okay, we have a volume question. What do we know is on the front cover? The formula sheet gives us the volume of a cylinder. However, I've memorised all these. I didn't mean to, it just happened. All right, so first of all, how do we figure out the volume of a cuboid?
Height times length times width.
Yeah, we're going to do height times length times width. So I'm going to write this down. This is base times height times width equals our volume, doesn't it? And this is our cuboid. Now, you don't have to write this exactly. However, I like to write down what's happening. This really helps you later on. What is our base? 12. So I'm going to substitute in 12. What is our height? X. What is our width? 5. And what does this equal?
60x.
270. Okay? Because they've told us the volume equals 270. What I've done here is I've translated this wording into a mathematical sentence. I haven't actually worked anything out yet. I'm just writing this sentence that's in words into a mathematical sentence. It's really important we can go from worded questions to mathematical sentence. And this is just basic knowledge. Everyone knows how to do a volume of a cuboid. Everyone should be able to get this mark. Now from here we can do some manipulation. So we know, okay, we know this. If we want to, we can carry on with this for a second. What's 12 times x times 5? This is 60x equals 270. Can I go one step further? I can. I can do divide both sides by 60. What does x equal? 9 over 2, which is the same as 4.5. Now, 9 over 2 is a nice fraction, okay? It's a rational fraction. I would write it as 4.5. However, if I had 1 over 9, for example, that's 0.1111 recurring, I would leave that as a fraction. But this is one decimal place. 1 to 2 decimal places I would convert to decimals, or else I would leave as fractions. Sometimes I just leave them as fractions. So then, our next sentence, the radius of the cylinder is x, the height of the cylinder is 2x. Now, lucky for us, we actually already worked out x, didn't we? So if we wanted to, imagine we didn't know this, though. Imagine we didn't know x for a second. Reverse, imagine we didn't do that. Imagine we read the whole question and we didn't know x at right now. Let's just write, it wants us to work out the volume of the cylinder. Okay? How would we work out the volume? First of all, I label my cylinder. My x is my radius and my height is 2x. Using the formula sheet, the air volume is volume equals pi r squared multiplied by height. Okay, they've given us this in the formula. So now to write my sentence using my x's, I'm going to have volume equals pi times my radius is x, so brackets x squared times my height, which is 2x. Okay, this is my number sentence now, my mathematical sentence for what we've done. However, we don't need to actually do that because we've already worked out that x is 4.5. So straight away we could, if we wanted to, our radius is x, which is 4.5. Our height is 2x. So what's 2 times 4.5? 9. So we can go straight to here. So we know volume equals pi times 4.5 squared times our height of 9. So I can put this into my calculator. So because it wants it to the nearest whole number, I have the volume is 572.55 to the nearest whole number. This is 573 centimetres cubed. And there we have it. Okay, we've shown all of our steps. We've learnt some new skills that are going to help us. Right, next, part B. It says change 1 metre cubed to centimetres cubed. Okay, so this is a scale factor question. I want us to have a look at something. If I had centimetres and I was going to metres,
Divide by 100.
I divide by 100, yeah?
Yeah.
Okay. Now, if I went from metres to centimetres, times by 100. So we're all happy with this conversion. So our scale factor is 100. So if I go from metres squared to centimetres squared, I've squared everything. So what should I also square?
100.
100, the scale factor. So I need to multiply by 100 squared. If I go from metres cubed to centimetres cubed,
You cube the 100.
I'm going to cube the 100. So if I have 1 metre cubed and I want to convert centimetres, I'm going to do 1 multiplied by my scale factor cubed. This is going to give me my centimetres cubed. So 1 times 100 cubed is going to give me 1, 0, 0, 0, 0, 0, 0. Can anyone tell me what this number is?
1 million.
1 million. Amazing. I've got 6 zeros, so this is 1 million. So 1, 1, 2, 3, 4, 5, 6. Also, just to say earlier, we didn't write on the line. Please make sure you write on the line, okay? Write all your answers on the line. So that was really simple, okay? Always go back to this. And remember, this is just scale factor. This is how we work with similar shapes as well. Question 6. Now, they always have these questions. It's basic algebra questions. So let's have a look, shall we? So, first one is make C the subject of A. Okay?
Times y to both of the sides.
So, what we're going to do is I always think, what was the last thing we did to C? Okay? Think about C here and tell me the story of C in words. Imagine we started with C. What was the first thing we did to C? We divided it by y, didn't we? So the first thing we did to C was divide by y. Then what did we do after we divided by y? We got C over y, didn't we? Then what happened after that? We subtracted 5z. And that's how we ended up with 6 over y minus 5z. Perfect. So if I want it to be C equals, I'm going to go backwards. What was the last thing I did to C? I minus 5z. So what do I need to do to undo that? I need to add 5z.
Yes.
Okay? So that means the first thing I need to do is add 5z to undo that. Yeah? Now, I'm left with c over y. What was the next thing I did? I divided by y. However, I would now times by y. Okay? So, let's see. This is what I'm going to do to the other side, isn't it? Okay, because this is the opposite. So now to get c on its own, remember, when we have equations, this is balancing. So the first thing I'm going to do is what? I'm going to add 5z to both sides, because we still want the quantity to stay the same. What we notice is these two cancel. Minus 5z plus 5z is 0. And I now have a plus 5z equals c over y. Okay, what was the next thing I now have to do? Multiply both sides by y. Okay, so if I multiply both sides by y, a plus 5 times y, it's that whole thing multiplied by y. So this would be y lots of a plus 5z equals c over y times y. I'm just going to break this down to really give some understanding here. C over y multiplied by y is the same as y over 1, isn't it? We can cancel the y's because they have a common factor. C over 1 is just c. This is what we're doing here. So our answer is c equals y lots of a plus 5z. If you went a step further and expanded this bracket, you would still get full marks. So now we're going to have c equals y a plus 5z. Okay? And remember, when we're making c of the subject, we're not changing the quantity of this expression, we're just rearranging it. That's all we're doing, is we're just manipulating it to look slightly different. Brilliant.
I never knew how to do these type of questions.
Well, now you know how to do them, don't you? So then, part B. Oh, I love this. Write down the value of g to 0. Anything to the power of 0 is? 1. Perfect. We should all know this. So that was an easy 1 mark. Probably the easiest 1 mark on the... Right. Next, it says factorize. We want to find factorize. Now, we know when we factorize a quadratic. This is a quadratic. Why? Because we have x to the power of 2. So, how do we factorize this? We multiply to give us 24, add to give us negative 11. Okay? We're going to have 2 brackets. We're just going to split this into factors. 2 numbers that multiply to give me 24. 12 and 2. Will that give me 11? No. 2 other numbers that multiply to give me 24. 8 and 3. Can 8 and 3 be manipulated to give me 11? Yes, minus 8 minus. So x minus 8 and x minus 3. Okay, let's double check this works first.
That's wrong.
Okay. X times x, x squared. X times negative 3, minus 3x. Minus 8 times x, minus 8x. Minus 8 times minus 3, positive 24. If I collect and simplify like terms, I'm going to get x squared minus 3x minus 8x is minus 11x plus 24. I know I am right. And I would do this right there and then to double check, because there's no excuse for anyone not to be able to get these 2 marks if you double checked. So we're going to get x minus 8, x minus 3. And there's 2 marks. Okay, 2 marks. Question 7. Kuro invests 50,000 yen for 3 years in a savings account. She gets 2.4% per year compound interest. 2.4% compound interest. Is this an increase or a decrease? Increase. So we have 100% plus 2.4%, because it's an increase, isn't it? Okay, or some of you might do 100 plus 2.4. What do we get? 102.4%. Now, when we're working with percentages, we need to show the multiplier method for the marks on the mark scheme. How do we convert 102.4% into a multiplier? We basically want the decimal form. The decimal of 102.4% is 1.024. This is our multiplier form, our decimal form. And we all know to go from percentage to decimal, what do? Divide by 100. We should all be fairly confident with this. So, we know we start with the original amount of 50,000. We have an increase of 1.024. How many years?
3 years. So
3 years.
Yeah,
So to the power of 3. This is our mathematical sentence. Everything is in the right form. What does this equal? We're going to put this into our calculator. So we get 53687.0912. Please write down the whole thing that you get first. Then it says correct to the nearest yen. So to the nearest whole number is 53,687. I have then rounded correctly. Remember, this is a 3-mark question. You need to show your multiplier for one of the marks. You need to have 50,000 times 1.024 to the power of 3 because it's 3 years. You have to have your answer and then your rounded version. Sometimes people just put 102.4% here. If you were to put that here and put to the power of 3, you will not get the marks. Your multiplier method has to be in decimal form. Question 8 is a 5-mark question, and I can already see the words, show your working clearly. Now, when we think about our presentation and how we lay this out, let's read the question first, and then we're going to lay everything out. When we're working with diagrams, I suggest you use a pencil, because then we can rub it out. It doesn't get messy as much, and it's better this way. So the diagram shows a regular pentagon, a regular hexagon, and a quadrilateral. What does regular mean? All the sides and angles are equal. So for the pentagon, all of these sides are the same length. This is actually the same for the regular hexagon. These are all the same length. So I'm putting this on here to show that they're all the same length. Now in this case, because the pentagon and the hexagon share a side, that's how we know that each of these is the same length. I don't know if the question requires this yet, but I'm just writing down what I know. And then the quadrilateral. Did it say the quadrilateral was regular? Did it say it was a rectangle or anything like this? No, so we don't know anything about this. Brilliant. It then says AEJ and HIJ are straight lines, okay? So this is a straight line. Even though it looks like a straight line, we've got to remember it says diagram not drawn accurately, okay? So they've told us it's a straight line. Okay, so I'm just going to write that down. It says work out the size of the angle marked X. Okay, so first of all, they've told us it's a straight line. What do I know about straight lines and angles? Angles on a straight line add to 180. So I know that these two are going to add to 180 and these two are going to add to 180. I know that, don't I? Okay. What do I know about a quadrilateral? Angles add up to 360. I know that's 180. I know this is 180. What do I know about a regular pentagon? What do pentagon angles add up to? 540. How do we know that? Now remember, you can draw triangles. How many triangles can you draw in a pentagon? 3. How many angles in a triangle? 180. How many triangles in the pentagon? 3. 3 times 180? 540. So we know in a pentagon, okay, angles equal 540 because we did 3 times 180. It says show you're working clearly. 3 times 180 is 540. How are we going to find one angle? How many angles are there? 5. So 540 divided by 5 equals 108. So I now know that each angle is 108 degrees, and I've shown my working. Okay. So that's that one done. If this is each angle is 108. So I'm going to use a different colour to show you. So this is 108, this is 108, this is 108, this is 108, this is 108. Does that mean we can work out this angle? Yes, because this is angles on a straight line. If I know this is 108, I'm going to have 180 minus 108 equals 72 degrees. So this angle in the quadrilateral is 72 degrees. We've worked out one of the angles. Brilliant. Okay. Next up, we have the hexagon. What do I know about a hexagon? How many sides does it have? 6. How many triangles can I make in the hexagon? 1, 2, 3, 4. So 4 times 180 equals what? 720. How am I going to find one angle? 720 divided by 6. 720 divided by 6 is 120 degrees. So I know that each angle is 120 degrees, okay? So all of these pinks are 180 degrees. Okay, now you can see how messy it's getting already. Is it a good idea to have pencil? Yeah. So 120 degrees. Do you remember this is 180? So how are we going to find this angle? 180 minus 120. Now I know you know that's 60. However, it's a show all you're working, doesn't it? So we have to write down that that's how we got 60, even though we did it in our head. So we now know that this is 60 degrees. I'm just going to draw this quadrilateral over here for us. Okay, this is X. We know that this is 72 degrees because we worked it out. We know this is 60 degrees because we've worked it out. Okay, what else do we need to work out before we find X? This top one, don't we? Let's have a look at this top one. I know, we didn't spot this earlier, but what do we have? Angles around a point add up to 360. We know this pink angle is 120 degrees. So we know for that point, 360 degrees equals 108 plus 120 plus that missing angle. I'm going to use a different colour. This orange angle is here, isn't it? Okay, plus this orange angle. So, this is my thought process. So I know that 360 plus 360 equals 228 plus that missing angle. So 360 minus 228. 360 minus 228 equals 132. So I now know that this angle is 132. And can you see here that if I'm not sure I can draw a box, this is the whole point. So now what do I know about angles in a quadrilateral? They add up to 360. So I now know that 360 degrees equals 72 plus 132 plus 60 plus x. And we're trying to find x. So 132 plus 72 plus 60 equals 264. So 360 equals 264 plus x. So x equals 360 minus 264, which is going to give us 96. So the answer is 96 degrees. Now, this is 5 marks, and you have to show most of this working out. Okay, let's get the mark scheme and see what we definitely have to show. So here are where the marks come from. Right, you get, I'm going to highlight this in pink. Okay, you get 1 mark for either 108 or 72. There's 1 mark for either or because one implies the other, okay? You then get 1 mark for either 120 or 60. Again, one implies the other. You then get 1 mark for this working out here. Okay? You then get another mark for you then get another mark, I don't think I would have got, for making sure that you've written this and then you've written 360 minus. If you did not write, if you've just written this and then put x equals 96, you will not get that mark. Okay? And then you get the last mark for 96. You do not get a mark for x equals 96 if you haven't written these previous steps. Okay, question 9. So, question 9, here we have. We want find the highest common factor of A and B. Now, first of all, we could do this in a few different ways. We can draw a Venn diagram, okay, and the highest common factor is what they have in common. So when we draw a Venn diagram, okay, this is A, this is B. If we look at 2 to the power of 8, 2 to the power of 6, what is the common factor? 2 to the power of 6, because 2 to the power of 8 can be written as 2 to the power of 6 times 2 to the power of 2. Okay, so we know that 2 to the power of 6 is what they share in common. So that means A has 2 to the power of 2 left, and B, it doesn't have it on its own. So we've done that, okay? And then I'm going to cross this out. Next we have 3 to the power of 5 and 3. What's the highest common factor of 3 to the power of 5 and 3? It is just 3. So we're going to write our 3 here, and then B's not going to have anything, but A is left with 3 to the power of 4, because not A, the whole thing is A here, but this is going to, the rest of A that's not included in B. Then we have 11. What's the highest common factor between 11 to the power of 4 and 11 to the power of 8? Absolutely, 11 to the power of 4. I'm going to put this here. Do I need to write anything in A? No, because I've used it all. How about B? 11 to the power of 4, absolutely. So, the highest common factor is actually our intersection. Okay? We don't have to work this out. We can literally just write 2 to the power of 6 times 3 times 11 to the power of 4. Okay? Now, there is another way that Dr. Frost shows us, and he is absolutely fantastic, and it's about the highest power winning, or the lowest power winning, depending if you want the highest common factor or lowest common multiple. And it is a great way, however, we need to understand the mechanics behind what's happening, okay? So, just quickly, if we have A, 2 to the 8 times 3 to the 5 times 11 to the 4, and B, 2 to the 6 times 3 times 11 to the 8, for the highest common factor, we look at the lowest power of a common base. So, lowest power of common base, yeah? And then for the lowest common multiple, we look at the highest power of a common base. A common base means, for example, we can't compare the 2 to the 3, because this is base 2, this is base 3. It needs to have a common base, so we can only compare base 2 to base 2. So for example, highest common factor of base 2s. We have these two to compare. What's the highest? The highest common factor is the lowest power of the common base. What's the lowest power? 6. 6 is lower than 8 of the 2s. Next one, what's the lowest power? 1. Lowest power of 4 and 8? 4. Okay, some people will know this method, some people it's new. I would prefer this way. or even if you write your factors like this, because this is now going to help with part B. So part B says find the lowest common multiple of 2a and 3b. Well, first of all, what is 2a? 2a is 2 times 2 to the 8 times 3 to the 5 times 11 to the 4. Okay. And because this is what 2a, it's just 2 lots of a. And then 3b is 3 times 2 to the 6 times 3 times 11 to the 8. So this is what 2a equals, and this is what 3b equals. Okay, we should all be happy at writing this step. Now, let's actually have a look at this. What does this mean? Well, this is technically 2 times 2 to the 8 times 3 to the 4 times 11 to the 4. We have a common base. Can we add the powers? So 2a is actually 2 to the power of 9 times 3 to the 4 times 11 to the 4. There we go. 3b is 3 times 2 to the 6 times 3 times 11 to the 8. 3 times 3 we know is can be represented as 3 squared times 11 to the 8. Now, if it wants the lowest common multiples of this, sorry, I think I've done a mistake. A is 3 to the power of 5, guys. So this is 5, sorry, this is 5, thank you. I've written it down wrong. There we go, 5, 5, 5, brilliant. Well done. Let's just double check, did I write everything else correct? 2, 8, 3, 5, 11, 4, check. 2, 6, 3, 11, 8. And I mean, this isn't a mathematical error, is it? This is a copying error. It happens. As long as we notice it. Well done to those who have noticed it. Now it wants the lowest common multiple. So I'm going to draw a Venn diagram again. Okay? So a Venn diagram of A and B. Okay, what do they share in common this time with our base 2's? What's the highest common factor of 2 to the 9 and 2 to the 6? 2 to the 6. So that means A is left with 2 to the power of 3. What's the highest common factor of 3 to the power of 5 and 3 to the power of 2? 3 to the power of 2. So what's A left with? 3 to the power of 3. And we know this is right, because 2 to the power of 3 times 2 to the power of 6. Is that 2 to the power of 9? Yes. 3 cubed times 3 squared. Is that 3 to the power of 5? Yes. Okay, now we have 11 to the power of 4 and 11 to the power of 8. What is the highest common factor? 11 to the power of 4, and then B is left with 11 to the power of 4, right? Now, the highest common factor is all of this multiplied by each other. So I'm going to get, the lowest common multiple is all of it together. So 2 to the 3 times 3 cubed times 2 to the 6 times 3 squared times 11 to the 4 times 11 to the 4. I need to simplify this. All my base 2's, what do I have? 2 to the power of 9. Base 3? 3 to the power of 5. Base 11? 11 to the power of 8. There we go. And then using Dr. Foster's method, where we did when we compared them, so 2 to the 9 times 3 to the 5 times 11 to the 4, 2 to the 6 times 3 squared times 11 to the 8. We always, when we do lowest common multiple, we do the highest common factor, the highest power of the common base. 9 is the highest, 5 is the highest, 8 is the highest. You can see that's also the answer. So that's how the two different methods work. Okay? And there we have it. 4-mark question. Question 10. Now, question 10 is a 5-mark question. This question says, show you're working clearly. And in the mark scheme, they're quite crucial about what needs to be shown. Also, this is the last question of the foundation paper. So the last question of the foundation paper is question 10. So we are still on foundation, technically. Okay? This is the crossover between foundation and higher. So let's read the question and let's see how we're going to lay everything out. The diagram shows one face of a wall. The face is in the shape of a pentagon with exactly one line of symmetry. So that means if we were to look at this shape, it has exactly one line of symmetry. If I was to split this shape down here, they are completely equal. I could fold it along this line and we'd have the same shape, wouldn't we? It'd be like a funky Christmas card, yeah? So, Armandi is going to paint the face of this wall once. So he's going to cover it in paint once. He has to buy all the paint that he needs to use it. The paint in each tin of paint he's going to buy will cover 16 metres squared. So we know 1 tin of paint covers 16 metres squared. I'm going to write that down as a mathematical sentence in terms of I've just made it shorter. We know what's happening here. Work out the least number of tins of paint Armando will need to buy. Show you're working clearly. Now, there are many different ways we could approach this question. However, I wonder which way you would have chosen. Take a minute to think how you're going to approach to find the area, and then we're going to have a quick discussion. Okay, so we've got two different ways. Way number one is the way I would have gone for because it's the simplest. This shape is a trapezium. Okay, so I'm going to find the area of the trapezium, times it by 2. So I've got 2 trapeziums. However, another way is to find the area of this rectangle and this triangle and then times it by 2. Either way, we're going to get the same answer. However, with both, we're going to notice something, that there is a piece of information missing. Okay, so we can do whichever one. However, if we were to do the trapezium, if I take this out, what do I need for a trapezium? Okay, I need my height here, okay, which is exactly half, we know that, 5. Then we have this part here, what's this? 6, okay. We then have this, which is 7, and then, the last one is this. Do we know what this is? No, we don't know what that is. We know, though, if we were to split this here, we know that this is 6, but we don't know what this height is. However, so this is 6 plus something, but we don't know what that something is. What do I have? What is this shape? It's a right angle triangle. I have 7. I know that this is half, which is 5, and I want to find this. So I need to use Pythagoras. So Pythagoras is a squared plus b squared equals c squared, where c squared is our hypotenuse. I have c squared. Well, not c squared, but I have this. And then I have a, so what am I trying to find? B. So b squared equals c squared minus a squared, which equals 7 squared minus 5 squared. 49 minus 25 is 24. So b squared equals 24. What does b equal? The square root of 24, which is, your calculator might also say 2 root 6. So this is actually 6 plus 2 root 6 is this length here. So if we were to use the formula of a trapezium, or you can use the rectangle and the triangle, I'm going to use the trapezium. This is given to us in the formula book. It's a half a plus b, where a and b are the 2 parallel sides, times our height. Okay, so we're going to have a half. My a is 6, my b is 6 plus 2 root 6, all multiplied by my height, which is 5. So I'm going to put this straight into my calculator, exactly how this looks. This is going to give me 42.247 ... Okay, so this is one trapezium. How many trapeziums do I have in the whole shape? 2. So I need to multiply this by 2. What do I then get? 84.49 ... Now, how many tins of paint? What am I going to do? I'm going to divide this by 16. What do I get? Okay, this is roughly 5.3. So I need 5.3 tins of paint. Can I buy 5.3 tins? No, I'm going to have to buy 6, because if I buy 5 tins, I'm not going to have enough for the whole wall. If I buy 6 tins, I'm going to be able to cover the whole wall. So 6 tins of paint. Perfect. Okay, so now this is the end of all the foundation questions. Question 11 onwards is higher content only. Okay, question 11. So, the manager of a call centre asked 120 people, so that means the total of people was 120, who rang the call centre last week, how long they each waited before their call was answered. The table gives information about their replies. Complete the cumulative frequency table. Now, even if you've never been taught this before, if we were to use common sense, it would help us. Let's read the table properly. Between 0 and 5, how many people were called? 8. Between 0 and 10, how many? 15 plus 23. 15 plus 8 is 23. Read 0 to 15. 0 to 15 is 8 plus 15 plus 17, 40. 0 to 20, so we're going from 0 all the way up to 20, we're going to get 68. From 0 to 25, we now need to add on 33, 101, and then from 0 to 30 minutes is 120. Now you know you're right if your total is the amount of people that were here, because this is the frequency, and if you read down the left hand side you can see these are all 0, 2, 0, 2, 0, 2. Okay, now this is then going to help us plot the graph. So we need to make sure on our we have a pencil in our hands, because that's the only way we're going to draw a cumulative frequency graph. Please get your pencils now. So what we're going to do is we're going to plot the points, and we're going to plot them by using the last number on the interval against the cumulative frequency. So the last number against this. Okay, this is how it's going to work. So for the first one, it's 5 and 8. So 5 and 8 is here. The next one is 10 and 23, 10, 22, 23. And can you see, what do we then have? 15 and 40, 20 and 68, 25 and 101 is in between 100 and 102, and 30 and 120. There we go. So I've now plotted all the points. Now what you need to do, once you've done that, you're not allowed to use a ruler for cumulative frequency. Now personally, you can't see this, but I'm going to turn this upside down so I can draw it. Okay? So if you have your paper in front of you, turn it upside down, and then I'm going to go left to right. So I'm going to go like this. Oh. Wait there. Okay. It's a lot harder doing this on an iPad. There we go. Okay, so you can see this is a nice curve, okay? And I do find it easier upside down. So there we have it. I hope that worked. I don't know, I was pressing all sorts of stuff then. Right, so now we've drawn it, okay? please do not use a ruler to connect the dots. You will not get the mark. It then says, use your graph to find an estimate for the median of the times weighted. Well, if we had 120 people, the median out of 120, once in order, and this is all in order now, is 60. You need to show that you have gone across 60 using a ruler. And then once you get there, what are you going to do? You're going to go down. There we have it. So we can see this is 15 to 20. We know this is 17.5. Each one goes up in twos. So this is 18.5. 18.5 minutes. Okay, what have you got on yours? Some people got 19, that's fine. Right, the next one says using your graph. Now this one, you can see it says use your graph, using your graph. You definitely have to show, using your graph, you have to show ruler lines. Find an estimate for the percentage of 120 people who said that they waited longer than 23 minutes. Okay, where is 23 minutes?
It's just all through 23, 6 out of 12.
Yeah, it is 6 in. So, oh my angle's all off, but be here and then.
I heard you say 80.
Okay, so I get 88 people, right? So, 88 people, okay. But how many waited longer? So what's 88 to 120? 32 people. 32, what's the percentage? So 32 out of 120 times 100 is going to give me my percentage. So we're going to have, okay, 26.67. Okay, so it doesn't say, I would round it to one decimal place, 26.7%. Okay, so in the mark scheme, the range here is between 17 to 20, if your graph is correct. And the range here is between 25 to 29%. Again, they're still looking for the same working out though, so that's really good. They always have a bit of a range on this one because some people do draw their graph a bit funny. Okay, so 12a, we've got to simplify this. 16e to the 10, f to the 6, all to the power of a half. So 16 to the power of a half is 4, because it's the root of 16. E to the power of 10 to the power of a half, we multiply the powers. E to the power of 5. F to the power of 6 to the power of a half is f to the power of 3. Part B. Write this as a simple fraction in its simplest form. Forget about algebra. When we add fractions, what do we need?
You need a common denominator.
And we need a common denominator. What's common between 4 and 3? 12, okay? So that means 2x plus 1 over 4. I need to multiply this by 3 over 3 to get a common denominator. So I'm going to get 3 lots of 2x plus 1 over 12. Brilliant. And then x minus 2 over 3, I'm going to have to multiply that by 4 over 4 to achieve my common denominator of 12. And the reason why I multiply by 4 over 4 is because I'm multiplying by a whole one here, because I don't want to change the quantity of this. And this is why whatever I do to the denominator, I must do to the numerator, because I don't want to change the quantity. And 4 over 4 is the same as 1. 3 over 3, it's the same as 1. If you multiply anything by 1, you just get what you multiplied it by. So this becomes 4 lots of x minus 2 over 12. Now I could simplify this. This is 6x plus 3 over 12. It's this is 4x minus 8 over 12 by expanding the single brackets. Now it says add in the middle. Watch out for this. We're going to add them. 6x plus 3 plus 4x minus 8. Now, luckily, this plus doesn't affect what we're adding. But if this was a minus here, this would become minus 4x plus 8x, because minus minus, right? Watch out for that. So 6x plus 4x, 10x, 3 plus minus 8 is minus 5, all divided by 12. That is the final answer. 10x minus 5 and 12 do not have a common factor. So this is in its simplest form. Okay, part C. Given that 4 to the power of k plus 3 is the same as 16 times 2 to the k, find k. Now, whenever we're working with powers, the only way we can manipulate it is if they all have the same base. The lowest base here is 2. Could we write 16 as base 2? What is it? Yeah, so can we write 4 to the base 2? Yes, what is it? So 4 can be rewritten as 2 squared to the power of k plus 3. 16 can be written as 2 to the power of 4. And then we have 2k. Now all the bases are the same, we can manipulate. We know this raised to this power is 2 to the power of 2 times k plus 3. And we know that when we multiply with the same base, what are we doing? Adding. Essentially, because we now have 2 to the power of something equals 2 to the power of something, these are actually equal to each other. So we can get rid of the base 2 and say 2k plus 3 must equal 4 plus k. We now have a linear equation that we can solve. 2k plus 6 equals 4 plus k. Take away k from both sides. K plus 6 equals 4. Take away 6 from both sides. K equals negative 2. Now, I can be a bit intelligent and see if this is correct. Let's see if this is right. Now, we don't have to do this. However, we should be getting to the stage where we are looking at this. We're going to substitute this back into the original equation. 4 lots of minus 2 plus 3, because that's where our k is, should equal 16 times 2 to the minus 2, should it not? Okay, so let's see. What is 4 to the power of minus 2 plus 3? This is 4 to the power of 1. What is 4 to the power of 1? 4. So my left-hand side equals 4, right? 16. 2 to the minus 2 is the same as 1 over 2 squared. What is 1 over 2 squared? 1 over a quarter. What is 16 times a quarter? 4. Does 4 equal 4? I've now shown that the left-hand side equals the right-hand side. This is intelligent practical mathematics, where we're practicing, we're substituting back in, we're seeing what's happening. Now remember, once you've done all this, I've got a bit wrong. Please, can we make sure that we write the answer on the dotted line so that we can see all of our working out. Question 13. Here are two vectors. AB is 5, 3, and CB is minus 2, 4. We want to find as a column vector AC. So what I like to do with these types of vector questions is, the way my brain works is to draw them out. So think about A. If A is here, how do I get to B in column vector form? This means I'm going across 5 and I'm going up 3. Okay? And this gives me B. And then C to B means wherever C is, C could be somewhere else, I've got to go minus 2 and then 4. So if though I wanted to go from B to C, I'd technically go backwards. I'd go 2 and minus 4. Right? So if I'm at B and I'm going to C, I'm going to go across 2 and then down 4. So how do I go from A to C? Now, if you think about this, from A, I've got to go across 5 and then across 2 again. So what's that? 7. And then from A, I go up 3, but then I go down 4. So technically that means -1. Now, this is how I do it using a drawing. However, if I wasn't drawing, what we can do is to use a bit of formula. If I want the direction A to C must equal the direction A to B minus C to B. Okay? So then we can see using column vector form, we have 5, 3 minus -2, 4. This is going to give me 7 minus 1. So you can see there's 2 different ways to do this.